Okay, what I'm interested in doing with these here is basically taking our quadratic function that is in standard form, this ax squared plus bx plus c form, and actually rewriting it into vertex form, which is this ax minus h squared plus k. So the way we're going to do this is we're actually going to use the process of completing the square. So recall with completing the square, what we're trying to do is find a value for our c here in this 1x squared plus bx plus c expression here. We do have to have a 1 in front. But basically, what could we put in for the value of c that would cause this to factor into a square of a binomial? And the reason why we want to do this is because our vertex form is very characteristically having a squared binomial in it. So our method is to rewrite this so that, first of all, our c value is equal to half the middle term squared, half of our b value squared. But if that is the case, if c is actually equal to half of our middle term squared, then this will factor into a square of a binomial. Not only will it factor, it'll factor into this x plus b over 2 squared, where this b over 2 was the number you squared to get your c value in the first place. And so this is a procedural set of steps that you need to know how to go through. But basically, here's what we're going to start with. We're going to start by displacing the constant that we already started with. And so it is pretty characteristic to move that to the other side. And what we're going to do now is, well, first of all, assess the situation. What I mean by that is we need to have a 1 as an a value here. Now, because I do have a 1 as an a value, I can go ahead then and I can add in a number to both sides here. But what we're looking for is this value of c that would cause this to be a perfect square trinomial. So because I want my c value to be half my middle term squared, then my middle term being 4 here, I suppose we get 4 over 2 squared, which is 2 squared, which is 4. Basically, this would become a perfect square trinomial if I added 4 to it. And so because I added 4 to the right side, I also need to add 4 to the left side. Basically, all we've done so far is just move the constant out of the way and put in the constant that I want instead. But by doing this, we actually did do what we call completing the square. And so what do you say is, completing the square? What is completing the square? It is this adding on of this half of the middle term square in order to make this a perfect square trinomial so that it does factor down into this perfect square of a binomial. And furthermore, once we do get half the middle term squared in here for our c value, we say that it would have to factor into x plus half of our middle term squared. So knowing that half of my middle term was 2, that number that I squared to get this in the first place, I'm going to put that positive 2 right here. And on the left side, all I'm going to do is just combine like terms. I got y plus 1. So now the only thing I have to do to put this in vertex form, just move the 1 back over. We say x plus 2 squared minus 1. So it's pretty stinking easy now. We could find the vertex is at h and k. We have negative 2, negative 1. As a matter of fact, this would just shift left 2 down 1, and its vertex would lie right there. As a matter of fact, its axis of symmetry also would have to be at x equals negative 2. And so that would be this right here. X equals negative 2. And lastly, but not least, we would say using our a value of 1 here, which is the same a value that we started with, I know that as I go right 1, I would have to go up 1 from this point right here, and that these 2 points would lie on my graph. So the neat thing about this, completing the square, is that we could rewrite things into vertex form that weren't currently in vertex form, but were instead in standard. So what I did over in Desmos here is I put in this 4x x squared plus 4x plus 3, and we graphed it. But looking at it now in terms of its vertex form here, I know that it shifts left 2 down 1. Let me throw that point on the graph. And because the a value is 1, as we go right 1, we would only go up 1 from that point. And we could even put in our axis of symmetry here. We say x equals negative 2 would run right through the middle of this right here. So taking a look at our next, what I want to look at here, x squared minus 10x plus 21. Maybe I want to write this in vertex form. Currently, it's in standard form. So let's do this. Let's boot the constant. Y minus 21, x squared minus 10x. Thing is, I'm going to add on half the middle term squared, but only, if our a value is 1. So because it is a 1, let's go ahead and add in half of the middle term squared to both sides. So half of a negative 10 here would be a negative 5. And we get negative 5 squared comes out to be 25. So by doing this, we'll turn the right side into a perfect square trinomial, which perfect square trinomials must factor down into this form, which is what we want. And furthermore, the value that goes in here, again, is half the middle term, and that was something that we already found here. Half of a negative 10 is a negative 5. Now on the left side, again, You're just combining like terms. I suppose we'd have y plus 4, and the only thing I'd have left to do is just go ahead and move that back over. We have x minus 5 squared minus 4. So looking at this, we could say that our vertex is at h and k, 5, negative 4, and our axis of symmetry would lie at x equals 5. And so to go look at this graph here, let's go ahead and take a look at it. We notice that our vertex here is at 5 comma negative 4. Let me put this back up here. If I put my mouse on this, it says 5 comma negative 4, and then with respect to our axis of symmetry, x equals 5 there, if I were to slide this over so that x is indeed equal to 5, it would look like this. And then last but not least, we say our a value, being 1, would tell us that as I leave the vertex and go 1 to the right, I would also go 1 up on my graph here, leaving us at 6, negative 3. Okay. So for our last graph, what I want to do is I want to take a look at one that has an a value that is not actually equal to 1 yet. And so we get this here is the graph of our quadratic function. Let's rewrite this into vertex form and prove that the vertex is at negative 1, 1, and that we have an a value of 2 here. So as we normally do, and as we always do with completion of the square, what we do is we move the undesirable constant first. And so what we have here is a situation where we're going to displace the 3 to the other side. We get y minus 3 is equal to 2x squared plus 4x. Now, the thing that sets this one apart from the ones we've done before is that our a value is not 1. So always, if it's not 1, what we always do is we factor it out. And what we get left with on the inside is something that would have to have a 1 there if you factor out whatever this number is right here. Now, with respect to what's left on the inside of this, I would say, well, we have to take this positive 4 divided by this 2. This would turn this into a plus 2x. And what I'm going to write now is this plus c. Notice that if I'm going to complete the square, I add on half the middle term squared to both sides, but I have to have an a value of 1. So when we complete the square here, we're really completing the square only with this inside quantity. So we don't do half of 4 squared and add that to both sides. As a matter of fact, we do half of 2 squared and add it to both sides. So if we did half of 2 squared, we'd really get 1 squared, which comes out to be 1. I would want to add 1 to this side. Now, because when I redistribute here, I get 2 times x squared is 2x squared, 2 times 2x is 4x, 2 times 1 is 2. I've technically added 2 to the right side. So just like over here, what you add to one side, we have to add to the other. Okay, add to one side, add it to the other, add to one side, add it to the other. Here, we're going to add the same thing to the left side, so we'll say plus 1, but what we have to make sure we do is we take it times whatever we had factored out over here. And so what I end up with is basically on the left side, 2 times 1, which is 2. I get 2 plus a negative 3. I get this y minus 1. And on the right side, hey, you know what? We know this factors. And not only does it factor because we made it a perfect square trinomial, the number that goes in here is just half your middle term. And so the only thing we have left to do is actually carry this 1 back over. We get 2x plus 1 squared plus 1. And so looking at this, we would say, well, my h and k respectively are negative 1 and positive 1. And I would say that my a value is 2. And also my axis of symmetry here, we would say lies at x equals negative 1. So going and looking at this picture here, I'm going to change this to x equals negative 1. X equals, let's try this again. Negative 1, we'll put that on there. So you can see that our vertex is indeed at negative 1, 1. And our a value being 2 this time, 2. Look at your graph. As we go 1 to the right of the vertex, we go up 2. So that would guarantee that 0, 3 would also be on this graph here. And using symmetry, we could get the other side. Cheers.